Okay. Okay. Hi. So our next speaker is Naginder. Naginder is currently working as a senior technical specialist at Microsoft, and he specializes in providing data-driven solutions. And he's a well-known speaker in our local communities and international conferences, and for Microsoft as well, Microsoft clients. Yeah. Over to you, Naginder.
Yeah, let's start. I think I'll get some couple of minutes more to probably cover the whole session. So, hey guys, this is Naginder here. I'll be covering on the new uh, announcements on open source databases on Azure, which is MySQL, PostgreSQL, and MariaDB. So, before we start, a little something about me. I'm a technical specialist at Microsoft. Yeah, love to code. This is my GitHub, my LinkedIn link. In case if you guys want to connect, send me a request and we can stay connected on LinkedIn on that. Most of the demos and all that you will see, I will upload them on my GitHub account, and you can explore from there as well. So the agenda that I will take you through today in the session, the agenda is basically I'll talk about what is the current state of affairs on open source databases on Azure. We look back at what we achieved in terms of the architecture, the services and all that, what features we released over a period of time. And then we'll look at what are the new deployment options that are available, what is the architecture of the new deployment options, and when would you use what, right? So there are multiple deployment options, and when should you use what is again something I will discuss about. And then we'll go into a little, I would say, a little in depth of Azure Arc, which is a new hybrid offering from Microsoft. And we look at Azure, how Azure enables some data services which you can deploy on any infrastructure, and we'll look at some demos as we go along this whole thing. So this is the this is what we offer on Microsoft, for that matter, in terms of the database services. So you have Azure SQL DB, which is the one of the most popular database in offering from Microsoft. And we have a warehouse offering also of the SQL Server, which is a distributed database. And from open source world, we offer PaaS services of PostgreSQL, MySQL, and MariaDB. And it all leverages the same database platform that we offer from Azure perspective. And then from backbone perspective, this all leverages the Azure cloud, the geo replication capability, the storage capability of Azure, and also its availability in more than, in fact, this is an old slide, it is more than 66 regions now. And one of the unique proposition of Microsoft Azure is its ability to integrate these various PaaS services to other PaaS services like Power BI, Azure Data Factory, machine learning, or cognitive services. So these are existing deployments that we have. We'll go into each deployment one by one, but prominently we had two type of offering. One is single server offering. Another is hyperscale offering, where you could take a Postgre single server instance and expand it to multiple nodes. The idea here is to scale out the database engine. So we'll talk about both of them. From a single server perspective, the way we offer this service is again very unique and not something that you will see in other cloud for that matter, right? The way it is unique is essentially when you go to other cloud and deploy a PaaS services, essentially they deploy it on a VM, right? And that's how you would have experienced maybe AWS RDS for that matter, if you have used it, right? But here on Microsoft, what we do is we have tried to decouple the storage in the compute. The compute runs in its own container. Storage uses the Azure blob storage, actually not blob storage. So let me just say Azure storage here. So it uses Azure storage, which maintains 3 copies of your data. And there is a gateway across every region. So let's assume I deploy a PostgreSQL on US West region. There is a gate cluster of gateways for every region. And behind that gateway is your container, which is running the binaries of your database engine. Now, same architecture applies to MySQL, PostgreSQL, and even for that matter, SQL Server. Right? This is a proven architecture, and the way it works is with this architecture, we are able to give you 4 nines of SLA. And how that happens is, so let's look at 2 big problems that any DBA is worried about. One is data loss and one is compute loss, right? So because we use Azure storage and it maintains 3 copies of data, if something has to happen to a data, Azure storage on the back end will because it's a software layer, you don't have to worry about that. But on the background, it will automatically spin up a new storage layer and make sure the data is replicated and thus maintain 3 copies of your storage, which is essentially a very fantastic option, because now I don't have to worry about data loss here. Anything that the database engine commits is made sure that 3 copies of that particular data is available at any point in time. Now let's look at what happens if the compute goes off, right? Now, in case if the compute goes off, the database management service, or you can call this as the service bus, which essentially orchestrates all the resources that are deployed on Azure, that will quickly know that the database container is down. It will quickly spin up a new database container, and the gateway will reroute your connection to the data storage layer, and that's how within a matter of seconds your clients can again connect to the new host, right? But again, you don't have to worry about changing the connection string, because you are simply connected to the gateway, and gateway will reroute your connection to the appropriate compute. This is a very I would say exciting architecture for that matter, because now even if something happens to the compute, you can make sure that within a matter of seconds, actually we say 60 seconds, but usually it happens much less than that, your connection will be redirected to the new compute and you can start your application. Important point to note here is that your application logic should have a retry in it to make sure that this happens. Okay, it is very important to code a proper retry logic in your application to be able to implement this kind of a high availability that we talk about, right? And be it any client, right? The same architecture applies, whether it's MySQL or PostgreSQL for that matter. So this is what single server looks like, right? We have another deployment option, as I said, which is Hyperscale. Sorry. Now, in a typical PaaS database, right, it's a block growth for that matter, which means you can grow in blocks. You can add more CPU, you can add more memory, you can add more storage to your database engine. But it's not a distributed distributed growth, or I would say it is not a scale out approach for that matter. It's a scale up approach, right? So in that case, what are the other options, right? Now this is where Hyperscale comes into picture, because what Hyperscale offers is a true scale out capability, right? As you can see from the right side of my screen, I can add multiple worker nodes. Each worker node can be configured to have from 2 to 64 vCores, and the storage can be increased from 100 gigs to 2 terabyte for that matter, right? Or more than that. Once you configure this, we will automatically rebalance your data to make sure that it spreads across all the nodes in a uniform fashion. and then you can begin your query. Now, I spoke about few things here, for example, worker nodes, shards. So how it actually works, right? So take an example of a typical query that you fire on a normal database engine, right? If you do this in a typical single server, or as the industry calls it SMP architecture, the database engine takes this query and then constructs a plan, an execution plan, and a storage access plan to ensure that the data which is in the storage layer is brought to the compute, and then compute formats it and gives it out to the client. But in a Citus, what happens is essentially when you okay, let's look at the architecture first, right? So in Citus or Hyperscale, the it's not a single server database engine. It's a distributed platform. It's a massive parallel processing platform. What this means is your data is not stored in one server. It is stored across multiple worker nodes, and your data is distributed, and each distribution is what is called a shard. So let's say if you have a table called table X or whatever, we will horizontally partition that data and spread it across multiple worker nodes. Make sure that the data is uniform when it is spread across the worker load. And then when you query this data, you will always query the coordinator, and coordinator is what will do the query fan out based on the logic that is written in the sharding as well as the query. For example, let's say I have a campaigns table which has been spread across multiple shards. These name of the shards or nodes is something that you will not have to worry about. That is hidden from you, and you just call that table as whatever table name that you would have given it. And imagine I'm doing a average group by company ID, right? So let's say my campaigns have been distributed as company IDs into these worker nodes. What would happen in that case is, since I'm going to do an average, which is nothing but sum of all the options divided by number of options, each worker node finds the sum and count, and then sends that back to the coordinator, and coordinator will aggregate that query to the next level and then send you back the result. So this is how Citus works, and it has been proven with my experience with some of the customers that I have worked with. Citus or Hyperscale can give you a boost of performance to the tune of anywhere around 5 to 10 times of what you see in a single Postgre instance, for that matter. So this is a very good value proposition for workloads which require higher transaction throughput. Or second option would be if you're building a multi-tenant application which has multiple customer data, you can spread that customer data across multiple worker nodes and make sure that you have more compute power for your workload that goes against a particular customer or multiple customers for that matter. The other important use case that can be implemented here is also a high transactional analytical processing kind of a workload, a typical HTAP kind of architecture that we see, where you want to do OLTP and OLAP in the same database. This is where you can leverage hyperscale distribution strategy to make sure that you can not only have transaction throughput from multiple worker nodes, but you can even leverage the aggregation capabilities to make sure you can run OLAP queries on the fine granular data as well. So these are some of the workloads or patterns that you can implement in a hyperscale. So looking back with this two architecture and some of the features that were released, for example, in security, we offered infrastructure double encryption. For data at rest encryption, we offered customer managed key, which means customers could manage their own keys. We even offered from security perspective that the TLS version, the protocol that your client speaks to the database, you can enforce minimum TLS version so that all the modern clients can connect, and not the clients which have older protocol versions which are more susceptible to security breaches. From performance perspective, we offered read replicas, intelligent performance. A lot of my customers are actually using it. From manageability perspective, cost perspective, we offered what is called as reserved instances, which means you can reserve the Postgre instance for 3 years and pay lesser amount for that matter. And then storage auto grow, which means you don't have to worry about increasing the storage. It will automatically auto grow based on the usage of your PostgreSQL or MySQL for that matter. With these offers, with these features that were available and the enterprise grade features that we offered, we saw many customers adopting it. For example, HSBC, I think Patrick spoke about this in the opening session, and there are many more for that matter. Some of the ones that I'm working in Singapore or APAC region are essentially some of the biggest conglomerates that you might hear of. For example, insurance, one of the biggest insurance company here, one of the biggest data center provider. These are the guys who are using the open source databases that Microsoft offers, and it has been a very profitable business for Microsoft. Now, based on what we learned from the previous offerings, infrastructure limitations or the architectures that we were offering, we learned a lot from our past 1 to 2 years of running this open source databases on the cloud. A lot of feedback was given by customers, which was made sure that we improve the product using those feedbacks. And a lot of customers worked with us to come up with new offerings also. Some of the reasons for offering this was also how to make sure that the offering is more flexible for the developers to adopt. And that's where we introduced two major offerings, which is flexible server, which is more focused around simplified developer experience, and Azure Arc enabled Postgre Hyperscale, which is more of a scaled out Postgre, which you can deploy in any hybrid situation. So we will talk about these two things in the rest of the session. Let me first start by introducing what flexible server is. Now, flexible server was made on three basic principles, which is how do I make sure that I give you more control for your databases. For example, developers or customers were asking us, how do I isolate my network for a Postgre or a open source database in a VNet? How can I have access to more server parameters? Also, because this is an open source offering, we have to still maintain the patches and all that with the community is coming up with, which meant that we had to make sure that we get one monthly maintenance window to apply those patches. Wherein customer came back to us and said, okay, I want my choice of maintenance window, and I don't want to go with the with what the industry is. I'll give you a very typical example. One of our gaming customer, right, said that you cannot ask for a downtime either in the midnight or on a weekend, because that's where most of my customers use my application, right? Imagine a gaming application. Most of its use is either in the evenings or midnights, and most of it is on the weekends, right? So if I think of enterprises who say that, okay, weekend is kind of off business hours for me and you can do maintenance there, a gaming customer will not be able to satisfy with that, right? Because that's not their off business hours for that matter. That's where they were asking for a lot of custom maintenance windows. The second basic principle in developing this was, how do I make sure that if you look back the architecture, right? We had bifurcated or separated the compute and storage, but the provisioning of compute on a particular data center was still not flexible for the customer, right? For example, let's say I have an VM which runs my application, and I have a PostgreSQL database. My VM runs in a availability zone 1 of a data center, but I don't have control on where my PostgreSQL will be deployed. It could be deployed on any availability zone, right? Which means that my application and my database server would have some kind of latency, right? I'm not sure if you've seen, but in Europe, Microsoft has data centers which is size of 10 football fields, right? Which means one availability zone versus another availability zone, there could be a difference of 50 kilometers for that matter, right? Now, that means huge latency for their application if the application code is in one availability zone and database is in another availability zone. How do I make sure that the availability zone is something that I can choose as a customer, and then also provide zone redundant high availability on that? And then the other experience that most of our customer demanded was it should be more compatible and more cost optimization, right? So I should be able to stop a server when there is a need. And that's where flexible servers was born, right? So if you look at the architecture, it's very simple architecture. When you provision a flexible server, we provision a Linux VM which has the compute engine, and the storage is attached to that VM. The data log and the backup storage all are attached to the VM, and your application, if it is living in a availability zone, you can co-locate the database along with that, right? And for edge of a scenario, you could implement something like that, where you could say, okay, my flexible server stays in availability zone 1, and I will use synchronous replication to make sure that I have another copy in availability zone, which is the copy of my database here, right? So this will ensure that your databases are in sync, and if something happens to one availability zone, you can quickly switch over to the another one. So let me, okay, this is something which I will talk later, but let me show you a quick demo of this, right? So this is my PostgreSQL, which is the single server. You see that there is no mention of availability zone here. When you deploy, all you get is a server name, the location where it is deployed, the status, right? You can obviously create replication and have multiple deployments of that. You can create it in the same region or different region, but again, you don't have the option of creating a replica of this in a different availability zone, because that is not available to you or exposed to you. This is where flexible server outshines, because when you deploy this, you can ensure that it gets deployed in a zone redundant infrastructure, and you can have a visibility of where it is deployed, right? So this, you see here, my primary is deployed on availability zone 1, and secondary is deployed on availability zone 2, right? You have the choice. When you deploy a new PostgreSQL, you would be able to provide a option there, right? Let me quickly show you how it looks like. So let's say I want to create a new PostgreSQL, and I choose flexible server. Here, I will be given an option to choose which availability zone I want to deploy this in. And if I want to keep a zone redundant HA, I can just select this, and the service automatically will maintain multiple copies of your database, right? It is as simple as that. Now let's see how this makes a difference, right? So if you see, this is my database server, npg SQL flex2 database.this. And what I've done is I have written a small code here in C#. What it does is it connects to this database, and what you will see that what I've done is I'm connecting in loop, right? Which means it keeps firing a simple query, which is nothing but it sleeps for half a second and closes the connection, and then again opens the connection and does the same thing in a loop. Anytime something happens and the database connection cannot be opened, or if there is any other error, it will catch that exception and tell you what was the issue, sleep for another half a second, and then try connecting again, right? This is what I was speaking about, the retry logic that you have to write, right? So let me try to run this quickly here. Now what you will see is that it is connecting to my application, firing that query, half a second goes off, again keeps doing that, right? Now let's simulate a failure, which means what happens, right now my server is running in zone 1 and secondary is running on zone 2. Once I fail this over, automatically you will see that the application disconnected for some time, but it got connected again, right? Now for that, we have a API which I can call from a command line window, which is AZ REST, and I'm posting to this URL, which is my PostgreSQL flexible server, my server name, which is npgc flex. Let me change the server name here, which is flex2. And what I will do is I will restart this with failover, right? So this is the payload that I'm sending to my API. What this will do is it will fail over the flexible server to another zone, and that you will see here in some time. And you will also see here when I click on overview, this will fail over to the new zone in a couple of seconds here. So you see here the Postgre got disconnected at 53 minutes 28 seconds. Now let's see how soon it can come back, right? And again, what it is doing, it is connecting after 5 seconds of timeout again and again. It will keep on connecting back to that, and you would see that now the high availability of, because right now the server is failing over to another one. And same you can see in the activity log here as well. Yeah, let's give it some time. And you see my database is already connected back, right? Let me stop this quickly. And you will see that it was down for some second, which is 53:28. And within a matter of 154.3, which means within a matter of about 30 seconds or 20 seconds odd, it connected back to my database. Within 20 seconds, we were able to fail over to secondary zone, and you were able to connect back to the service again. You will see that the activity is logged here, which means my service was restarted and my service is available again, right? So this is what high availability we talk about when we say that it is zone redundant, which means something happens to one zone, quickly the other zone will take over and provide you zone redundant availability for that matter, right? So this is what flexible server HA looks like. Now let me see if okay, application stop. Okay, let's go ahead now. This is another feature that I was speaking about, which is the start stop, right? Essentially, you could start stop your database, and there is another option in the flexible server which is called as burstable compute, which means you don't most of your workload, right? If you look at their CPU usage, it are typically spikes, right? Which means that most of the time, if you have taken 2 cores, you end up using 0.5 out of that whole thing. In burstable compute, what would happen is we will not charge you for 2 cores if you provision 2 cores in a burstable, right? We give you something called a CPU credits, and when you use that, automatically we burst the database engine for more cores, and you are billed only for the amount that you use, right? So burstable CPU credits can be utilized for performance during peak hours and all that. We will give you more CPU credits to do that. This is very important for workloads like dev test, where you are not testing every day or developing every day, right? So whenever you are, you can consume those credits that you would have not consumed, for that matter, during a off-peak hour, right? So this is a very important capability that you can exploit in flexible server. Now, when to use what, right? You saw single server, we give you 4 nines of SLA. In flexible server, we give you zone redundant HA. It is a little different in terms of terminology, right? In flexible server, there is one more thing which you would see, but I cannot show it now. But in maintenance windows, you can go ahead and click on maintenance and choose the maintenance window, right? Now, reason this is offline is because if you go to the architecture, right, we failed over to this. What is happening now is that it is creating a synchronous replica in the previous zone, and that's why right now availability shows as grayed out, right? So you have to give some time before this happens, but that doesn't mean your database is down. Your database is running in availability zone 2. So we give you custom schedules, right? So which means if you have an application where you want custom schedules, you should choose flexible server, right? In case if you're leveraging Postgres 12 or 13, you should use flexible server, because that is where we will offer the version of 12 on, right? If you want stop start feature, use flexible server. If you want a network isolation through VNet integration, use flexible server, right? And then the other things are coming in, for example, managed keys, customer managed keys, reserve instances, cross-region replica. This is not available as of now, but will be available as soon as we GA this service. So right now it is in preview, but think of this as a more flexible offering where you can choose things like zones, you can choose things like custom schedules for maintenances. So this is a very important part. So let's talk about Azure Arc now. And before we get into Azure Arc enabled Postgre, I wanted to speak about what Arc essentially is, right? So we all know Azure is a cloud offering from Microsoft, which gives you capability of management, security, app data services. You have a lot of dev tools, DevOps available. But one of the most important feature which is kind of overlooked is that Azure offers a true hybrid cloud, which means you not only can deploy on a cloud, but you can also deploy on offline systems like Azure Stack, right? Which is an appliance that you can install on your own data center. Or else you can also deploy and manage infrastructure on any data center or any cloud for that matter. If you have a VM running on Elastic Compute running on AWS, you can tag that to Azure and manage it from there. You also have capability of Azure Edge devices, which is again a different offering for that matter. So how does it look, right? So Azure Arc essentially enables you to run data services anywhere, be it cloud, be it on premises, in any cloud. You get the capability of management across those environments. This will be available in online mode, which is not available in right now. It is in preview, and the only connectivity that is available is offline, which I will talk about a little later. And then you can adopt cloud practices on premises also, right? And biggest focus here is how do we make sure that the same level of security that you get on Azure can be implemented everywhere, right? Same, it can do vulnerability management, security management, and all that, right? How is it possible, right? So typically, if you know what Azure looks like, it has what is called as Azure Resource Manager, which is the ARM template offerings, which was based on the Azure Resource Manager, right? Basically, it allows you to, for Azure customer, to connect to Azure through Portal or Shell, Bash, CLI, or any ecosystem that can be developed on APIs or through Marketplace also. Whenever you provision something, you essentially translate into a Azure Resource Manager template, and this template actually goes ahead and deploys that particular service that you are adding it, right? Now, this essentially ensures that we can add more resources here. So let's say if I have to offer, for example, Azure Kubernetes services or Red Hat OpenShift, I just have to make sure that that service has a Azure Resource Manager compliant APIs, and then ARM can talk to that, right? So this is essentially how Azure looks like. But what happened with Azure Arc is that we extend this capability by Azure Arc. Now with this, the same ARM template can manage resource not only on Azure, but it can also manage resources on your customer location. It could be AWS, it could be GCP, it could be your on-premises, and connect to this through local tools like Azure Data Studio. If it is a Kubernetes cluster, you can connect to it through Kubernetes native tools or other admin tools as well, right? So this is how Arc enables you to extend your cloud to any location for that matter, and not just Azure. Again, the same slide here, and this is how Azure Data Services extend the Arc capability, right? Again, as I said, Azure ARM template will have the interaction with Azure Arc integration, right? Now, when you deploy, so let's say I want to deploy a database service on Arc, right? So essentially, it gets deployed. It can be deployed on any Kubernetes engine. It could be vanilla Kubernetes. It could be Red Hat OpenShift. It could be AKS or JKE, or any OEM hardware also. Essentially, what we will do is we will deploy something called as Azure Data Controller on the cluster, on the Kubernetes cluster, which essentially gives you the capability of integrating it with Azure. And then Azure Data Controller also exposes some API which can be used to interact with it. It also offers monitoring capability, HADR capability, backup capability, and patches and updates also. So let's say I release a new patch for PostgreSQL or SQL Server, automatically Arc Data Controller will take that registry and apply it to your SQL cluster which is running on Arc, or it could be PostgreSQL. And in future, we will offer more data services here on the Azure Arc as well, right? So this is essentially what it looks like to have Arc installed on your own infrastructure. So for a demo, what I will do is I will have a AKS cluster deployed on Azure, and there I will deploy a Azure Data Controller, and then we will deploy a PostgreSQL Hyperscale cluster on that. Now the steps are pretty simple, but it takes a lot of time to be able to deploy that. So what I've done is I have pre-deployed those things already, and then let's look at how it looks like on a Azure Arc. So again, I go back to my Azure portal, and I have a resource group called NARC demo. And there I have my Azure Kubernetes cluster, which is deployed there. And I have a jump box, which I use to manage this Kubernetes cluster and then deploy Azure Arc on top of it. In case if you're wondering how this could be deployed using a template, I will share a link with you which has the template detail, and with a click of a button you can deploy all these things automatically. It also deploys a PostgreSQL, and everything is given to you out of the box. I can show you what that template looks like. I had this deployed, taken from so GitHub. This is essentially what it has. It has the data services, deploy scripts, YAML files, and all that. It also has some jumpstart scripts so that it can deploy on AKS or EKS or JKey, or if you have your own cube, mini cube or something deployed, it can deploy there as well. Right. So I followed this ARM template to deploy a data controller, and then you can go ahead and deploy a Postgre Hyperscale on that, and then you can also deploy a test database on top of it, which is AdventureWorks, right? So let me show you what it looks like. So as I told you, it deploys a cluster, a Kubernetes cluster. It also deploys a VM so that you can manage it. In the Kubernetes cluster, this has essentially 3 nodes in there, which is the default configuration, right? But you can increase or decrease by scaling up or down. Minimum node size is D8, DS. You can choose whatever while you have to deploy it, right? And then it deploys multiple namespaces on that, and one of the namespace is the data controller namespace, which gets deployed here. And within this namespace is where your PostgreSQL will be deployed, right? So we'll check on that a little later. But you see here, you can look at a lot of things from here, right? For example, this also deploys various services as pods on it. For example, you know that whenever the AKS is deployed, it deploys a Grafana tool on top of it so that you can have metrics and other capabilities, have a kind of a monitoring dashboard on that, right? And that the PGSQL, PostgreSQL, which got deployed, you also have a public endpoint for it. Obviously, all of this is controlled by the VNet in which it gets deployed. And if you have to access it from outside, you will have to make sure that the relevant ports and IPs are exposed outside, right? So that I have already done. If you see here, I just went ahead and added everything for that matter, just for the demo. But you can make more controlled access here by controlling this. You can also give a source of IP as well here, right? Let's go back to the Kubernetes cluster here. And as I said, there are multiple services that are installed on top of it. One of that is Grafana. And I can so I'm accessing it by opening the port that you saw here, right? So this is the IP, and I access the port and /Grafana, and automatically this is what view I have, right? So it has some sample dashboards automatically imported into it. It gives me the host node metrics, pods metrics are exposed here. It also gives you things like Postgre metrics for that matter, right? Now again, this is how many what is the CPU usage, what is the disk usage, network usage, and memory usage, right? You can look at different container metrics also for that matter, individual containers. So when you deploy it, not just Postgre, but there are some additional pod containers also deployed in the pod. These are essentially to make sure that the Postgre monitoring capabilities are exposed outside, right? So Telegraph is a time series database. Influx is where it stores the data and then gives you capability of searching on top of it. Fluent is a open source container to for log search and all that, for storing logs and all. And Elasticsearch is again for you to search on that, right? And control DB is nothing but the data controller that I was talking about. So you get complete visibility on not just the host pods, but also the Postgre, right? So for example, if I want to look at Postgre usage, I can look at Postgre metrics. For example, what is the Postgre CPU usage? How much memory is it using? What are the rows returned, row inserted? And a lot of different things are exposed here by the PostgreSQL, which is deployed there. You can do things like table metrics are also exposed, and then you can look at SQL managed instance and all that as well, right? So these are some of the details that are available to you. You can fine grain it to a particular table or a particular database and look at those table statistics also. Now let's go back and see some details of the database that gets provisioned with this. Right. Obviously, we are just at the monitoring part here, but let's look at some of the other details. So for that, I will log into my VM here, and what I've done is I've kept some commands ready because I don't want to spend much of time here. And let's make this a little bigger here, okay? And so as I said, Azure Data Controller, let me increase the size of this. I hope it is visible now. So as I said, Azure Arc Data Controller gives you capability through CLI also, which is AZ Data. Now, this is the command line tool to manage the data controller on Arc and also manage PostgreSQL or SQL server for that matter, right? So first and foremost, you need to log in. My namespace is already as an environment variable, so I can provide that here, which is Arc Data Control. If you remember here, my namespace, which I provisioned in my when I was deploying this AKS, is an Arc Data Controller. So I'm connecting to this workspace here. And once I'm connected, then I can do things like this, right? I can, so this is the command to show the status of my data controller, AZ data DC Arc DC status show. And this will tell you whether your data controller is ready or not. This command will tell you how many servers have you deployed on this, right? So just one Postgre which I have deployed, and the name of that PostgreSQL Postgre server is nArcPGSQL, right? I can show more detail of this particular server group, as in how many nodes are there, how many worker counts, and all that details are listed here. So for example, if you see this output, when I see a Postgre, it tells me there are 3 workers. It is in a ready state. I am running PostgreSQL 12, version 12 there. And each worker node has a limit. But right now it has been given 256 MB and 5 GB of storage for backup and storage for data and log, right? This is my external endpoint. And this is my endpoint for Grafana and Kibana dashboards. So I can take this endpoint and connect to it. So I'll show you how I have done here. And again, because on my VM I don't have a modern browser, I had to expose it outside so that I can connect through my desktop. But here you will see that I have connected to my Arc database by specifying the same IP which you saw here, right? my ARC IP and the port number and the database name, username, password, and I am actually connected to that database now. And you will see that there are three schemas here: Citus, Citus internal, public, and within Citus there is a table called PG dist object, which is what you saw here, right? So this is where essentially you can connect through tools like PG admin and do your own stuff. For example, I can run a query here. I can say, tell me how many activities happening here. Uh, and then it will tell me how many users are connected to it. This is my PG admin, which is connected from the current session, and this is the statement that I ran here, right? So all that is just as any other any other Citus or Postgre hyperscale that you would have in any other data center or whatever, right? Now let's look at some of the other ways in which I can manage this server for that matter, right? So again, for AZ data is for you to manage your Arc data controller and Arc PostgreSQL, but your normal tools also apply to it. For example, I can say, tell me using this command, I can find out how many pods are running in my Kubernetes cluster, right? So there are, you will see, this is my Arc, which has one coordinator and three worker nodes which are running, and then other are your other pods are your essentially the metrics pod for which will have your Grafana, Kibana, the Fluent ID, IT. All those containers would be running in these particular things, right? You can also do something like this to find out how many nodes are there. Okay, I think I missed it. So there are three nodes which are running, which is evident. If you remember, I said that my Kubernetes cluster has three nodes. I can even find out where my pods are installed, which particular uh, cluster node holds my pods and all that. And I can even ask it to describe one of the pod, right? So if you see, I am trying to describe my coordinator in that, which is NRPGSQL1, this pod, which holds my coordinator, and it has multiple containers in it. So each PostgreSQL pod will have Fluent bit in it installed, because this is where it monitors the PostgreSQL. Then it will have your other pods also running, which is the Postgre pod, right? And then it will have other pods also listed there, and then the volumes that it has been attached to those pods, right? So this is essentially gives you some idea about how do you manage and install, for that matter, Azure Arc on any, and this is, I've installed it on AKS, but this could have been anywhere else as well, right? And there are multiple tutorials, multiple templates for you to deploy this. Let me know if there are any questions or anything I can help answer. Otherwise, when I share my PPT, I will share my the details of the templates and all that which I used for the demo as well. Okay, I think that's about it from my side. Thank you. Let's see if there are any questions here.
Yeah, I don't think
So
so. Thanks, Naginder. I have one question here. Hello.
yeah, please go ahead.
Yeah. Basically, for the PostgreSQL, you told initially that we do the sharding. So how exactly from the, the data from the sharding it's queried? I mean, like, is it don't affect any of the performance for? means like, because when we distribute data in different sharding, so how, because like in Cosmos DB we have means like when we do the sharding, so we can also query the data from different means
Yes,
data.
so same is applicable here also. If you go back and look at the simple animation, right?
Yeah,
So let's say if I have deployed or sharded my database such that my data is spread across multiple worker nodes, and if I'm joining them with other table, there is a concept of co-location in this architecture, right? So you need to make sure that the table, multiple tables that you're joining on, the relevant data or the joining key is the shard key for them, right? Otherwise, it will not give you good performance, because what would happen then is your query is not pushed down. Worker nodes are just supplying the data, and your coordinator will have to do the heavy work here, heavy lifting of doing the joins and all that, right?
yeah.
So yeah, those are some performance considerations that you have to do while designing the schema for this. But if it is well designed, it can give you much more boost, right? So I have had experience with some customers where we migrated them from other competition clouds like Redshift, and when they moved to Citus and we had a proper sharding strategy developed for them, we could see 2 times performance boost for them, right? So again, it depends on your sharding methodology. But yeah, you are right. If you have not sharded it properly, it can give you poor performance also.
Okay, thanks. One more thing, means like, is this database also provides like a global replication, right? Means like for the write performance as well, or is only the read replicas are there for that?
No, it is. Yeah, so it is not like Cosmos DB, which can globally replicate it. This is a relational distributed database, but for one region only.
Okay, sure.
But yeah, you can use the Postgres replication to create multiple read replicas or high availability set for this. We support that, but not cross region as of now.
Okay, sure. Thanks a lot, and really nice session. Yeah.
No problem. Thank you. And I think with that, I will stop sharing
Yeah.
and let me know if there are any questions still here.
Sure. Hi guys. There is a feedback in a chat window, so please help to provide your feedback. It will help to improve our sessions, and means all there will be lucky draw at the end of the webinar. So all the users who have done the feedback, so they will be selected. They might be selected for the lucky draw. So please help to provide the feedback.